Hi, my name is Ivo Jimenez. I'm a PhD student at UC Santa Cruz, and I'm gonna briefly describe what we're doing to simplify onboarding people to working with Ceph. And this is in the context of grad courses and classes, where at Santa Cruz we have quarters, so we only have 3 months for a class, and for a project we have very few time for the students to work on projects. And so what they end up doing is they work on experimentation workflows around Ceph. And what we want to do is to reduce the more we can the time they take in setting up and deploying Ceph and all that stuff. And basically we have two workflows. The one is like the one where you might be familiar with, which is you just compile Ceph, then you work on vstart, and then you compile again, and it's very interactive, you iterate very quick. And the other one is when you want to actually benchmark and deploy on a cluster and so on. So what we're doing is that we're using GitHub Action workflows. If you're not familiar with GitHub Action workflows, they're basically it's a workflow specification language that allows you to express a workflow and what would you do when that runs. And all of them are all of the stages in this workflow are containerized. So every action in this workflow, it's a Docker container that is running on a machine. And you can think of it as a kind of like a make, container-based make, and that's what we use it for. So we can give a student a fully functional end-to-end workflow, and they start with it, and that's what they start working with. And we have a tool that allows you to run workflows locally in your machine, because GitHub Action workflows run on GitHub. But with this tool, you can run it locally in your machine. And so the first one, it's very simple. It's just one action. You just have an action that builds Ceph and generates everything that is necessary for a student to work with vstart right away. So the output of this action is a container, and they just once they compile this, they launch the container, and then they run vstart internally, and then they can work on it. And the other nice thing of GitHub Actions is that, as you can see, there's all the parameters are documented in the sense that they're in the workflow. Everything that you pass to CMake, it's there. And so when a student modifies something, then they can commit this workflow file and then can explain why they changed and why they changed it, and it gets recorded on the Git log. And then we extended it with two other tasks that allows you to push these packages to some repo. And then we move on to the next workflow, which is the actual benchmarking. And again, we have another workflow that allows you. The nice thing of GitHub Actions is that they have actions for a bunch of clouds, so you can get resources, for example, on AWS or Packet or any other cloud. And you can, in our case, we use an NSF sponsored cloud. It's a cloud for doing experiments, and we again have everything that the workflow is doing in terms of benchmarking, what is running. In this case, is running CVT, and what are the parameters to CVT, the config files. Everything is on the repo. And to wrap up, this is what we're doing. What we want to work on later is to work on containerized on a container-based workflow that it's going to be using Rook and CVT. And that's it. Thank you.